Welcome DIERS user. Welcome to this presentation of the DIERS Academy, Module A, Part 2, Motion Lab. Before we move forward, I would like to state that it is important that you either have a look at the first part first or that you are already mastering the use of our posture lab. Because within this presentation, we do use some concepts that are based on the concepts that are discussed and that you use within our DIERS posture lab. Now, this presentation has been divided into 4 sections, where we will first have an introduction on the dynamic measurements, why to use them, how to prepare for a measurement, review and processing the measurement data, and post-processing the measurement results if necessary. So we'll first have a look at the why and how of measuring in locomotion. Analyzing the human body during locomotion is analyzing the human body in function, which is very different from analyzing that human body while standing still. Our system gives a perfect holistic approach to gait abnormalities. And the reason I'm saying this is because all gait labs at the moment are still limited to the use of markers, to the use of cameras, but without going into detail in the spinal function. Our system is the only system that allows you to do locomotion measurements, including the posture and the spine itself. As we use various measurement devices for the holistic approach, which means that we use our 4-metric system for the spine and posture, we use leg axis cameras to get a good view on the gait analysis of the legs, and we use a pedigate system, which is a treadmill with an integrated pressure plate for pressure analysis. These 3 systems together give you the holistic approach, but in some cases, you might want to use just one of them, which is perfectly possible. It is, of course, very important that your patient can walk on a treadmill and not just can walk on the treadmill, but that the patient is accommodated to walking on a treadmill. As such, it is not wise, of course, if someone is standing on a treadmill for the first time to immediately start making measurements. The best thing to do is to have the person on a treadmill for a couple of minutes to make sure they are very well, let's say, trained to walk on a treadmill, and then you can start making measurements. Now, how to select speeds and stuff like that will be discussed later on. But as I said, it is important that you make sure that you get a natural walking pattern or running pattern, which only works if the person is accommodated to the treadmill itself. What is different in comparison to the static approach to use the system? Not much. The operation of the treadmill is extremely simple. It's operated from the software. That means that you don't have to manipulate the treadmill itself, and it also means that the patient cannot manipulate the treadmill. So that's really easy. It's straightforward. The second item that changes is that you have to use reflective markers on pelvis and neck. While with the static system, we say you don't use markers if you don't have to use markers. With the dynamic systems, you have to use markers. The reason is, especially on the dimple points on the PSIS, these points are extremely difficult to auto-track if you don't use markers because of the muscles that are activated. How to prepare for a measurement? Well, in terms of environment, it's not too different from using the posture lab. You need a proper ambient light, and you can have no direct light source on the patient. This is quite straightforward, and this is also something we take very much care of when installing the system. One thing that is a bit different from just the ambient light and from just the room itself is that you have to make sure that no one is on the treadmill while initiating a measurement, including pressure analysis. The reason is that when you activate the pressure plate is set to 0 for all sensors, and as such, you cannot have any weight on the treadmill during this offset regulation. For the patient, you have to lower the underpants halfway down the buttocks. You have to tie up the hair that we have the upper vertebrae good visible. You have to take jewelry off, like earrings, necklaces, even watches, just to avoid any possible reflections that you don't want. And as I said before, in this case, you have to apply markers. Now, applying markers, how to do that? The general rule is that you have the markers available close where you are preparing the patient, that you don't have to run around. It's easier to have them with you, and that you use a pen and a long ruler because it is easier to palpate and mark the anatomical landmarks with a pen, and then afterwards apply the reflective markers. Once you get used to this, you will see that this way of working actually is way more precise and goes quicker also. So all these points that we discuss in detail later on, it is best to point them out with a pen first and then to place the markers. Very important remark over here, the more precise the markers are applied, the more accurate your measurement results will be. If you, for example, place this knee marker too much to the lateral or too much to the medial side, it will change the Q angle that you might want to look at. For the 4-metric system, so the system that will give you the readings on posterior and spine, the markers that we have to apply are the C7, so cervical 7 vertebrae, which is the vertebral prominence. So you palpate the process spinosus and you apply the markers. And you also apply markers to the dimple left and dimple right, or the PSIS position. You have to have these 3 markers. In individual cases, for example, in scoliosis care, or if you see any deviations that you think might hinder the measurement from finding the symmetry line or finding the process spinosus line, you can apply extra markers along the spine's processes line. But once more, these 3 points here, they are absolutely necessary. Without them, you can't make the measurement. Where to apply the markers for the posterior leg axis system? Well, the ones we have in our system are the PSIS, the posterior superior iliac spine or dimple points, the middle gluteal fold, the middle of the back of the knee, the meeting point of the medialis and lateralis muscle gastrocnemius, calcaneus upper edge, calcaneus lower edge. For the calcaneus upper edge, I often use the insertion of the tibia of the Achilles tendon. It's just important that this upper edge and lower edge do reflect the position of the calcaneus. And if desired, fewer markers can be used, so you can check that within the DIERS software. I will also come back to this in the presentation. But for an example, if you only need the inversion, eversion of the calcaneus and the pronation, supination of the calcaneus in relationship to the lower leg, you use these lower 6 markers and you avoid using the upper 6 markers. The leg axis lateral is even easier to set up. You have a marker on the trochanter major. You have a marker on the lateral knee joint, the malleolus lateralis, base of the foot proximal calcaneus and base of the foot distal mediodorsal head. An important remark for privacy issues is that if you use the side leg axis camera in combination with your 4-metric system for the spine, the breasts might be uncovered for women. And then you want to limit either the view of the lateral camera so that you don't have the breasts inside your recorded image. Or you might want to cover the chest area with a modesty drape or a sticky bra. Another remark that I discussed with one of our users a couple of weeks ago. If you're doing running measurements, so if you're working on higher speeds, don't go for the modesty drape, but go for a sticky bra. Because if you don't support the breasts during higher movements, they definitely will influence your motion pattern. So depending on the wish list, fewer markers can be used. As discussed before, you could say, I would only like to focus on the pelvis. Then use only the pelvis markers. And in my example, I already told you, you can use only 6 markers on the lower leg. From the side, it's easier if you either use no markers for documentation purpose. You have only 3 markers, which would give you the knee angle and the hip angle in relationship to the ground. And if you use 5 markers, you have this hip angle, knee angle, but also the angle that you can calculate from the sagittal view. Preparing for a measurement with a pressure system might be the most easy system to use purely for making measurements. You can do it without shoes. You can do it short condition. As I said, while initiating the measurement, you cannot be on the pressure plate. This one will be given in the software also. Just be careful if someone has never been on a treadmill before. Please start in short condition, as a short condition gives more stability to your patient. So the first minute on a treadmill should always be in short condition. And then you can still see whether you take the shoes off for the first measurement, yes or no. If you use shoes, please cover reflective areas. Running shoes often have reflectors inside so that you're good visible when you run inside the dark. But these reflective areas will hinder the automatic landmark or the automatic marker detection within our software. Formatic height of projected lines, very similar to what we do with the postural lab. The medium thicker stripe should be at the level of the angulus inferior for the scapulae. This line's exact height is insignificant. It does not make any difference at all. In case of the motion, you just have to remember that as well the upper area here as the lower area here have to remain inside the projected area during the measurement. During walking or during running, patient is moving up and down. Just make sure that you have stripes available above the vertebral columns and that you have stripes available on this pelvis area. If you use a combination with leg axis, make sure you have no stripes on the markers you want to measure. The LEDs are automatically activated. It's slightly different from the poster lab where you have to do this manually. But as we expect the use of markers in the motion lab, the LEDs will be switched on automatically for you. Now, let's focus a bit more on patients walking on a treadmill. We do know that there is a slight difference between walking on a treadmill and overground walking. But the main advantage of using the treadmill is that you create an infinite gateway that you can repeat the speed. And you also show that patients walk at a more or less stable speed during the measurement. The ground moves under the patient, not the patient over the ground. So that does make a difference in sensation for the patient. And people are normally also used to have some air resistance while moving. These two things make it important to give your patient a bit of time to get accommodated to the treadmill. If you get sporty people in or people that have been on a treadmill before, you'll see that within 30 seconds, within 1 minute, they are perfectly walking on a treadmill. Now, people walking on a treadmill have to remain within the marked area and the feet have to be seen completely on the preview image in the pressure. But if you stay within the marked area, the feet will always be within the pressure area. Achieve a fluid, natural gait. As I said, you want to get an infinite gateway where you can compare the different contacts between each other. That's the main advantage of using the treadmill. But an important item is that you select an optimal speed. Now, for mathematical or scientific reasons, there is always a discussion: should I fix the speed or should I not fix the speed? Well, in clinical conditions, I would say don't fix the speed. And you will often even see that if you measure barefoot, that the speed during barefoot measurements might be slightly lower than the speed you have in short conditions. Now, okay, then the question is how to select the proper speed and why select the optimal speed? Optimal speed gives you repeatable gait pattern, gives you a natural stride length, gives a calm and harmonious upper body movement, has a good arm pendulum, and it gives a sensation to the patient that is walking naturally also. Now, the way I select the speed is by keep increasing the speed until the patient has the feeling that the speed is a bit too high. So I often start at 2 km per hour, move up to 2.5, 3, 3.5, 4, until the patient tells me, well, this feels like a bit faster walking or a bit faster running as I'm used to. Then I switch back the speed with half kilometer per hour, and that's often the most reliable, most repeatable speed for that patient. So that is important. As you can see, we give visual representation in our system. We give direct feedback loops. You can even have a visual look at whether someone is still compensating for the treadmill, yes or no. Once you get a very fluid, very repeatable movement pattern, you can start recording the image. Okay, if you press the recording button, once all your preparation have been done, the system will record in general for 5 seconds. In an emergency, you can stop the treadmill using the red button. But while recording, the loading bar will show you how far the recording has progressed within these 5 seconds. And just before the measurements stop, you could tell the patient if you want. I don't do that myself because once the 5 seconds are finished, the system will slowly slow down in small steps and will stop completely. So it's not like the system will stop immediately. The patient will definitely feel that the system is slowing down. And after all data has been saved, the processing will start. Now, just a small remark, if you only make a pressure measurement or if you only make the spinal measurement, saving the data is pretty easy. If you make recordings with as well the spinal system as all the leg axis cameras you have as the pedigate system, saving the data, of course, will take some seconds. Review and processing of the measurement data. Now, general remark, the more used you are to the system, the better your ambient light environment is, the better you take into account that your patient has to be accommodated to the treadmill, the easier the review and the processing of the measurement data will be. For the spine, just check your first picture. Is the patient fully in the picture? Not just fully in the picture, but is the patient also having the lines on top of the C7 and below the dimple points? All markers found? As you can see here, vertebra pons, dimple left, dimple right. Are there no reflections, for example, because you forgot the watch or because you forgot the necklace? And is the symmetry line clinically possible? If yes, you can proceed and the system will recalculate or reanalyze all the images behind image 1, which means another 299 frames. If you get some reflections from the area around the system, you might crop the image. Image cropping means that you tell the system to look at a limited view in comparison to the complete view of the camera. This could always work to get a better and stable computation for analyzing. Once the analysis is done, you could play the image, the reconstructed image, to look at the trajectories of various vertebrae and to see whether they are harmonious and whether they are plausible. If yes, you save the measurement. Once more, if you take care about your environment, if you take care about your patient, you should reach 90 to 90% of the cases where you can simply trust the analysis without editing the measurement. Leg axis. Similar idea as the 4-metric system. The more care you take about the initial measurement, the easier it will be to reconstruct the marker points. In the first picture, verify all markers are found and correctly assigned. In this case, on the left image, they are not, because the system does pick up the dimple points and does pick up some reflection points along a projected line just above the underpants. As you select in this case 10 measurement markers, not the pelvis, you can crop the frame, so adjust the frame in such way that you discard the upper area. Worst case scenario, you can remove, add, or move markers, and you could even insert black boxes to avoid specific areas. You have all possibilities to actually digitize the first image. And once you digitize the first image correctly, if you proceed, the system will automatically start calculating the other 299 frames. Once more also here, the more care you take about the initial measurement, the easier this processing and reviewing will be. Pedigate also here, often this is the most easy, system to analyze, as the system automatically recognizes left and right foot. And this is in most cases is spot on from the first time. When you work with neurological patients and you get unexpected, pressure measurement patterns while the gait is not, let's say, the most neutral or normal and natural gait you could have, it might be that the system makes mistakes between left and right or starts making mistakes in the separate contacts. Also, here we have various corrections options, swapping right and left, changing stride length, and even add or delete frames. Worst case scenario, you can delete all frames and you can manually edit each separate contact. As mentioned, in some specific clinics with neurological patients, they have to go through the manual process for the various measurements, but still you get an enormous amount of information from these repeated contacts you can measure on the system. Apart from editing left and right contacts, you can edit the force curves, and you have to do this because when you start recording, you will always have, well, maybe not in running, but in walking, you'll always have one foot in contact with the ground already. As you can see here, you only have a contact that is partial. It's not a full contact, so you have to cut that out. It's easy using the sliders below the graphs that you cut away those contacts that have not been fully recorded. And this is important for the mathematical calculations and standard deviations later on. Segmentation, this is something you can do. It's not necessary. It depends whether you use the segmentations in your analysis. The segmentation often is done correctly, quite easy for barefoot measurements. If you do measurements in shoed conditions, often you have to fine-tune if necessary. Just to give you an example, it might be very interesting to look at the metatarsal 1 area, because the pressure reading could give you an indication whether you have rigid hallux valgus or a very flexible hallux valgus. If you want more information on that, you can always contact us, but it is wise, to consider using the segmentations in a lot of cases. Post-processing of the measurement results. Now, similar remark as with reviewing the measurement results, the more care you take about your initial measurement, and in this case, the more care you take about the initial review, the less post-processing that needs to be done on measurement results. Post-processing as in reanalyzing the measurements. Another way of post-processing the measurements is what you do, how you report the measurements. Reporting is very easy. In each result page, you will find a printout function. A printout function, gives you the possibility to either hard copy printout on paper or to PDF export, PDF print if possible, and send it per email. Frequently used pages can be saved as a default. There are always also export formats in screenshot, AVI, BMP, and APT format. So we do give you the option to report on the measurement in various conditions. If you create an AVI format, for example, of a patient walking on a treadmill, that AVI file can be seen or can be exported to any other computer, where our measurements can only be opened with the ICAM software. So we do give the possibility here to export and to show measurements on all sorts of operating systems. User manual for all these products can be found under the section Help. And as mentioned before, if you need additional help, we are always available with a team of application specialists that you can contact through the company, and the company details can be found here. Then I wish to thank you for your attention. Please explore more of our videos on the website, and then, I wish you a good day. Thank you very much.